Hi, so I'm Anna Roth on the Microsoft Cognitive Services Computer Vision team.
I'm Chris Sinkovich. I'm a developer on the Custom Vision service.
And today we're going to talk to you about CustomVision.ai. So this is a new service, Custom Vision service, that we have for building custom image classifiers. So what is a custom image classifier? Well, you take an image, give you a result, and it's based on the categories that you train. The real goal here is that you should be able to build a classifier in on the order of 10 minutes, and you only need about 50 images per class to get started. So kind of in this example here, I have gotten, you can't read this probably, but cypress, fern, hemlock, a bunch of plants. I want to recognize their leaves, and I have about 50 images per class. I can train in 1 to 2 minutes, so it's very, very fast to start training, and I can iteratively improve it. So at the end of training, I get a API endpoint. Don't copy my keys, folks. I will be very unhappy. So at the end of training, you have an API endpoint. You can send your images there. Don't read my keys. And you also get all of your predicted images sort of saved. So it's a very, very fast tool for building custom classifiers. We'll go through the UI a little more in the end, but the really neat thing about the Custom Vision service is that all the APIs that we use to build this website are also public. So actually, Chris is going to walk through and say, let's say you don't want to touch the UI at all, how you can go through the process of building a custom image classifier super easily, just using the SDKs and APIs we've provided.
Okay. So like Anna said, one of the things we started with Custom Vision is that we wanted to make this a platform as well as just a website and a service that you can use. So we started out by building a set of REST APIs, and that's actually what the website uses. So every single thing that you can do on the website and every operation you can perform, this is actually calling the same REST API that we have under the hood. And you can actually open up the Network Explorer, you can go in and you can see it do that. So this means that you can plug in at all different points, you can do any different thing you want to, and basically anything we can do in the website, you can do with your programs too. Everything is, we've open sourced, well, the client stuff is open source on GitHub, so you can go to github.com/Microsoft/cognitive-customvision-Windows, and there we have the client library, and we've also published a sample application. So this gives you a small walkthrough that shows you a few operations you can do with it and how you can get started using this service. So our APIs are kind of split into two sections. We have the prediction API and we have the training API. And you can think of the prediction API as being your sort of public API surface. This is what allows you to make predictions with your trained classifiers against images coming out from the wild. The training API is kind of your private management service, and that's how you can interact and create projects. It's how you can add images, edit tags, all the things you can do through the website, you can do through the training API. So we've kind of cleaved them into two, and you can think about it as the public and the private side of things. The first thing you'll need when you're interacting with the APIs is to be able to get an API key. As we said, we have two sections, so we have two keys. You can go to it by going to the website. If you go up here and click on the cog, you can see up here we have the training key. So we have these two keys, and again, remember the training is private, and this is for you. This allows you to manage and edit your projects, and you have your prediction key, and this is more public. It allows users to send images to your service and actually make predictions. So once we have our training key, the first thing we can actually do is go in and make a training API. We go through, so this is using the C# SDK. The C# SDK is published on NuGet. You can get it today by going to nuget.org and searching for Custom Vision. And there's two packages, one for training and one for prediction. So again, for whichever operation you're doing, and you'll need the keys for each. So the first thing you can do, you can create your training credentials, pass in your training key, and you get an instance of the training API. At that point, you can go in and you can start creating projects with a single line of code. Our API is very sort of entity-based and works in similar ways for all the different things. We have entities for projects, we have entities for images and tags, and essentially you'll notice that for every entity you have a corresponding create, get, update, delete kind of call. And so you create things by passing a bunch of parameters in, and it will pass you back this project object. So here we say create my new project, and it gives us an object back which represents that project. If you want to edit or update these objects, you can edit the representation of the entity locally, and then you can call update passing that entity back in. So we try to be a very entity-focused API, and it really is all about grabbing and creating entities and adding them to projects and moving them around. So once we've created our project, we can go in and we can create some tags. We'll just create two simple tags here. This is hemlock and Japanese cherry. These are two leaf types. Hopefully you saw the leaf classifier in the keynote yesterday, and the sample app actually ships some of that data so you can play with it and get started straight away. So once we have some tags, it's simple enough. All we have to do is upload some images into them. We support two ways of uploading images. You can do them one at a time, or you can do them in a batch. So one at a time, it's simple. We just loop over our images and say, hey, here's an image. It belongs in Hemlock, and we can supply our training data this way. Or we can actually give it a batch. So we have a whole batch of images. We do support a max batch size, which is 64. But we'd actually also recommend not sending it every time. Obviously, it's a single network call, so the bigger the batch, the more likely it is to fail. The website uses something like 20 images, and we find that works really well. But it's pretty quick, and you can very quickly upload quite a lot of data doing that. These will return an image entity, and you'll get a status, and so you can go through and check the status of each one. So if one image in the batch fails, it won't fail your whole batch. And so this is all about trying to get lots of data into the service as quick as possible. And you can go through and see which ones worked and which ones didn't. So at this point in time, with these few lines of code, we have a project, we have some images, and they're tagged. So the next thing to do is train it. So we issue this train project call. Now, the thing to notice about training a project is it's essentially asynchronous. Now, we try and be as quick as possible, but ultimately it takes a few minutes to actually get it trained. So we're not going to sit there and hang and wait. So what happens is train project returns you an iteration entity. An iteration represents the point in time of your project, and these are what you can actually predict against. You have different versions of your predicted endpoint. So this will give you an iteration, and that iteration currently, its status is training. It's actually doing something on the server. And so you have to just sit there and we poll the server and check until this iteration's ready. So essentially you have the iteration, and it's currently training. Here we're just thread sleeping for a second, and then we are asking for that iteration status again. And so we just loop until that iteration's finished. You can kind of play around with the sleep settings to try and get something that works for you. Currently, we actually, because we're still in early launch, we're actually throttling users to the API at 2 calls a second. So there's no point trying to query faster than 500 milliseconds. We'll just start blocking it at that point. So a second is probably roughly what you want to be doing. So at this point, we've now got our iteration. It's trained. We have this notion of default endpoints. So where you can send images to a particular iteration, we also have the default one. So you can just say, hey, this is the one that normally I want people to do if it's not for testing. So here you can see that update I was talking about. I've got the iteration, I make a change to it, and I issue an update call with that entity. So at this point in time, with just a few lines of code, we've created a project, uploaded the images and tagged them, and now trained it. We have a fully working image classifier in the cloud with a REST endpoint ready to go. We can start making predictions against it with just these very few lines of code. So how do we do that? Well, we use the prediction API. Now, we said that the keys were on the website, and you can use them. But also, because we have the training key, we can actually programmatically grab this key as well, because the training API is kind of the superset, and it's your private one. So you can say, hey, I'd like to grab the prediction key, so we ask for our account info, and we can get this prediction key. Obviously, you can also just go to the website and paste it in. In the same way we did with the training APIs, we create a prediction endpoint, we pass in our key, and we've now got something that we can use to call images. So we can make a prediction. We say simply, predict image, and it will give us our result. And the results here will be an array of predictions. It's a prediction for every tag that's in your project and its associated probability. So you probably want to apply some thresholding and say over 80%. Here we go, and it will show you what's in this image. But with just these very few lines of code, using custom vision, we've trained a classifier and we've made predictions against it. And we can now start doing as many things as we want with this. So it's one of the things we think is really nice. I mean, I don't know if any of you ever used like TensorFlow or the Microsoft Cognitive Toolkit and looked at the Getting Started docs, and they're like, oh, it's very simple to build a classifier, and you need lots of data, and you need to do this training, and at the end of it, you end up with this model, and you don't know what to do with it. Here, in just a couple of lines of code, you can have an image classifier and already start making predictions. And you could go and embed this in your application right now and use it to add intelligence to your applications. One of the other things is that, as I said, everything on the website's exposed, so including things like getting the predictions that are coming to you and adding them in and helping to iterate your project to make it better. And because we're an open platform, these are REST APIs, you can plug it into anything you want. So you're not limited into our service. So if, for instance, you wanted to take the images that are coming in and get a human to classify them for you, you could plug this into Mechanical Turk or Crowdflower and actually start outsourcing that work. And so we're providing the basic machine learning and the underlying infrastructure so you don't have to, but you can still use it however you want to and make it work for you, essentially. So as I said, the NuGet packages today are available. You can go get them for C#. And there's REST APIs, so you can plug them in anything you want. It's not out yet, but we have Python and Node.js SDKs coming. And our API is also fully Swagger compliant. So if there's other clients you want, we publish the Swagger files. You can just go generate them and do whatever you want with them. Yeah, so that's how we feel that you can plug into our service and build on top of it.
So very, very fast, very, very cool. And everybody, super happy for Chris, who actually went through and kind of did all the API definitions, built all these SDKs. It's great to have him here. We're going to spend 5 minutes kind of talking through one more thing, which is how you actually go through and kind of iteratively improve your classifier. So obviously kind of the programming model, very straightforward. We also have kind of a model for how we think of you using Iris. Obviously, we're going to do this through the UI because it makes it easy to understand. Come on, Windows. All right, can I just log into your, do you have an account logged in?
It's logged in with currently the demo too.
Perfect. All right. So when you think about building a classifier, the way in which we encourage you to do this is to do it iteratively. So most people that start building a classifier think, wow, I have great data, I'm ready to go. They'll upload their 30 to 50 images. The classifier will be pretty impressive, but it often turns out not to be that close to what they want to actually do in the real world. Maybe it's because you have glossy marketing images. Maybe it's because you got lots and lots of different backgrounds and lots of different colors, but didn't actually fix the lighting. This happens to us all the time. It happens to us when we're building new classifiers. And it can be kind of a tricky problem to deal with, because at the end of the day, when you're building an image classifier, you want the data that you are going to be encountering in the real world that you're trying to make predictions on to be as similar as possible in underlying properties to the data that you've trained on. So kind of the model that we see you using here is that you build your classifier. It's very, very fast. You're 10 minutes to getting a prototype classifier. You deploy it. You start testing with it. And with that, we actually help you sort of make it better over time. So as kind of was mentioned earlier, so we just trained. Oh, you have not submitted any active learning images. Oh,
sorry.
let's try this one. So what you don't see here, but what we'd like you to see here, and you will in 10 seconds, is that every image that you're sending to the endpoint is being saved. So in this other demo here, wow, that's magic. If we head to our prediction tab, we can see these are all the images that were sent to the classifier, and we've ranked them so the images that we think that you should be labeling are near the top. So these are things either that we were not particularly high confidence about, or that are very, very recent, and so it's likely that it's kind of to be relevant. So kind of spending your human time labeling things near the top are the things that where you can have the biggest impact on improving your classifier. So I can take something like this plant here, which is guessed as a rhododendron, but I actually know is a Japanese maple. Save that tag, go to my performance page, train. Actually, I tagged that in my last demo, so it's already been tagged. Let's get this one as a fern. So if I go and hit fern, save and close and train, and once again, I'm doing this in the UI. You can do this entirely programmatically. Hit my key there, my limit there. 30 seconds?
20 seconds.
Give me 20 seconds. If I was to hit train, you would see within 1 to 2 minutes I would have a new classifier that I can then kind of continue to test on. A lot of the stuff that we won't have time to go into today for this session, but was covered in the custom vision session, are all the little tips and things that we've built in here, the little heuristics, the little kind of visual cues to help you kind of debug what's going wrong with your classifier. So you can do things like filter by probability threshold or show the images that are likely to be wrong according to your classifier. So there's lots of little tools and heuristics that we've tried to build into here so that you can see how do I actually kind of improve my classifier over time. We took the things that we learned building things like the computer vision tagger, the landmark API, all those like little weird kind of like rules that you learn when you do this before, we've tried to build in here automatically so that all you have to worry about is getting the right data and kind of improving it. All the kind of like arcane knowledge, all those heuristics have already been built into the tool. So we've got 5 minutes left, and this was supposed to be interactive, so we've got 5 minutes for questions. After that, we will hop off stage and continue to answer questions for as long as there are people here. But I guess if anybody have any questions? All right, well, since there are no questions, no one's raised their, oh, yeah, there we go. All right, we're gonna have to walk up to people. Yep, so there's a question about kind of the back-end processing and also charging. So right now, this is in public preview. So you can all sign up today if you go to customvision.ai. And I would encourage everybody that took the 25 minutes to listen to this tech talk to actually sign up. It's in public preview. You have a quota because it's free for kind of the public preview. We'd encourage you to give it a shot. And
these are just the addresses where you can get the NuGet packages, where the sample is.
Let's add in the actual site.
Oh, yeah.
Customvision.ai. So you can sign up here today, use your MSA. That's customvision.ai. And if you're standing here right now not doing anything, I'd encourage you to pull out your phone or pull out your computer and sign up because it's very, very fast. And if you have some images, you could have a classifier 10 minutes from now. Yeah. So thank you for popping by, and we will be around to answer more questions.
Thank you.